What's up, folks? Welcome back to the channel. In this video, we're going to be talking about how to create research reports using LLMs. And essentially, we're going to start with a very basic implementation of writing a research report just by prompting a model like ChatGPT. And then we're going to evolve that. And the framework we're going to be looking in today is going to be LangGraph. Essentially, when you go to build a research report, the basic workflow that you might go through is something like you create an outline, then you create a first draft, and then you review that first draft, and then maybe you create a final report after a few iterations. And obviously, the process of creating the outline, creating the drafts, and reviewing it involves a little bit of research, right? You go online, you find some papers, you find some articles, you find some videos, you find resources that help you, improve the quality of that report. And then over time, through iteration, feedback, and analysis, you reach some final report. So how could we do something like this using AI? So I set up a little VS Code notebook here. I set up a little notebook to just start this conversation. So in this first example, what I'm doing here is I'm essentially just prompting the model. In this case, I'm using GPT-4o Mini because it's high performance, super cheap, and super fast. And I'm saying you're a helpful research assistant. And then I send it a topic. I said, how to use large language models for augmenting human research workflows and enhance human learning, scientific discovery, and decision making. And then I have a prompt that's going to take in this topic and it's going to send that to ChatGPT. And the prompt is write a research report on the following topic, and the topic is the one that we've just discussed, right? So we send that to a function called create research report naive. We send that prompt to the model and we get a response back. That's it. That's what we're doing, right? And actually, this variable here could go inside this function because it's just about it just takes in that function, etc. So prompt research report will go here. So it takes a topic, creates the prompt for the model, sends that to the model, and we just have a little function that does that. Perfect. That's great. So now, what we would like to do, right? The thing that we get out of this is not that great. I mean, this is the output that we got from prompting GPT-4o Mini right away. And I mean, it has a lot of interesting ideas, data analysis, interpretation, collaboration, networking. They're all like very, very simplified, and that's all fine. The suggestions for how to use it are interesting, although none of them are referenced. So we have no idea where the model is getting these ideas from, although we know that since the model was trained on the internet, you know that this information is available somewhere. But what really gets to me is that when we get to the end, we have these references, which are references to papers that somewhat have some connection to the topic we've pointed out, but they seem like a middle point between hallucination and low quality. They're most of them, I mean, make some sense, like attention is all you need. Yeah, sure, it's related to large language models. But for this particular topic, it has no bearing and it has no importance. No one needs to know about, how self-attention works or how these different mechanisms work to really grasp how to use large language models in practice to augment human research workflows, etc. So my point is, although this looks like a good, okay report, and it has some interesting ideas, it doesn't really serve as something that I can use because I can see here that the references are not really connected to the contents. None of the sections are actually referenced anywhere, and it's not good quality. So at this point, we might look at this and we might say, okay, so let's break the problem down into 4 parts, okay? And this is something that, when you learn basic prompt engineering, you learn about the importance of some very simple strategy. There's actually a great guide by OpenAI. It's called the Prompt Engineering Guide, and it has 6 interesting strategies. And the most important things you should know is you should be super clear when you're prompting the model, so no vague requests. You should break things down into parts and then prompt part by part instead of asking for the whole thing at once. And you should use reference text. You should ground the model's answer in text instead of asking the model to, solve a big question without giving it much reference, especially if you want detailed information, precise explanations, etc. So let's start by breaking this problem down into these 4 prompts to outline, draft, review, and final report. And let's see if we can get a better performance, okay? So now I have a little function here that just calls the model with a prompt, okay? And then I have 4 prompts. I have the prompt for the outline, I have a prompt for the draft, I have a prompt for the review, and then I have a prompt to create the final version of the report, right? So the prompt for the outline, it says, create an outline for a research report on the following topic. That's it. Then the prompt for the draft says, create a draft for a research report on the following topic, following the structure of this outline, okay? So we use the information of the outline to feed to the next iteration of this model, right? We're chaining prompts together, which should not be something new to you if you're used to working with these large language models, if you've encountered frameworks like LangChain, etc. Now, the next prompt says, review this draft that we created, given the original topic for a research report, and then we give the topic. So now the reviewer is gonna do the review given what already happened before. All right. Then what we're gonna do is we're gonna say, write a research report on this topic, integrating the feedback given for this early draft, write the final review version below. All right, so this is essentially the package of 4 prompts. And of course, there are like slightly better ways that we could do this, like appending these things to the messages. We're not gonna get engineer about this because the whole point is to understand more the problem of creating the report rather than, creating an optimized app or anything like that. Okay, so when I do this, I get a much better research report. So as you can see here, we have enhancing human research workflows using LLMs, and then we get a background with definition, evolution of LLMs, the trends, and then the importance, a purpose, and then we get a second part, and then a third of about augmentation, everything explained and kind of, it's a much, much better quality in terms of the report itself. It's a bigger report. And the only issue with this second version, right, is that when we get to the end, we get this very weird hallucination-ish kind of output, where instead of having the references, we get site relevant literature, so it's kind of like this meta comment on, including the references instead of actually including references to papers, links, etc. So much better version, but we still have this problem of not having, references to cross-check the output information of the report, which would be key for a high-quality research report, right? And even though this is a much better version, this flaw in it kind of makes it not really usable as something that we could, on a day-to-day create, make, an AI produce a research report on whatever topic we're interested in, etc. So what would be an ideal scenario in this situation? Well, an ideal scenario, I think, would be something like we start with the model searching for relevant online resources, right? And then reading through these contents, and then first filtering out which are the relevant resources versus which are not, and then discarding those that are not relevant to the original topic of the research report we want. Finally, we store these, and then we use these to generate the bulk, the content of the report. So now everything can be grounded in something rather than being something like, a lot of high quality output of the model, but we don't really know where the information is coming from, right? So we would write the research report based on those sources rather than just having a report with no reference. So we look at this and we think, okay, we're modeling this problem as a graph, right? Which happens a lot when you're working with LLMs. You start modeling things as graphs. You start building little diagrams of like, what do you want the flow to be? You want the model to first do this, and then maybe get information from there, and then integrate this, etc. And because we're doing that, it would be nice to have a framework that was made for making these kinds of reports, making these kinds of workflows where you can model things as graphs, where you control the nodes in the graphs and the edges, etc. And that's exactly what a framework called LangGraph is made for, right? LangGraph, which is a framework created by LangChain, is a framework that's created to produce workflows with large language models that can have a non-deterministic side, meaning a side of it is going to be controlled by large language models, and also a deterministic side, meaning a side of it that's going to be just executing a specific function to do a specific thing. Something like, for example, formatting the output of a web search or something like that. Okay. So if we look at a new version of this plan, we can think about it in terms of, okay, we would like to have some input topic. We do that research online, right? And that research online involves this process of filtering out stuff. And then we would create the outline, create a draft, write a final version of the report, right? So let's take a look at an example of how to do this. And this is an implementation that I did, which is like essentially a slight modification and simplification of a documentation example from LangGraph. But I think it's quite pedagogical into explaining how we would get about this and get something, relatively good in the simplest way possible, let's say, okay? So for this example, we're just going to be using search in general, like search and archive search, and we're not going to be doing any RAG. We're not going to be doing any extra, pipeline infrastructure thing, because we want just a simple way to create the best version of a research report possible with referencing to sources, etc., without getting too much out of hand in terms of complexity, etc. So, okay, let's take a look at how we would do this. In LangGraph, you start things with a state. A state is going to be something that starts in something that you initiate when you start your graph, your workflow, right? And they can be updated. It's going to be updated as it goes through nodes and edges. Okay, so it's going to be something that has some attributes. And it's going to be defined as this type dict object. And essentially, you're going to have some attributes that can change over time. Okay, so in this case, we're going to have three attributes. We're going to have input, essentially the input topic of the research report sent by the user. We're going to have chat history, which is going to be a list of all the messages exchanged between the user and this it's going to be a history of all the messages exchanged in the history of the workflow, of the execution of the workflow, including obviously the messages exchanged with the user, right? And then we're going to have something called intermediate steps, which is this very weirdly defined object right here, which essentially says essentially this is going to be a list, okay? And this list is going to be something that can be incremented over time. And what's going to be incremented is something called agent action, which is an object representing the actions of an agent. Because sometimes when you give an agent in LangChain, in this case, let's focus to LangGraph. When you give an agent in LangGraph some action, and when it performs an action or it performs multiple actions to solve a task, those actions get stored, right? They get stored at these individual, they can be stored at these individual agent action objects, which is how LangChain represents actions in their framework. So this is going to be really useful. So we understand how the agents, what was the process the agents went through to solve the tasks, okay? So that's intermediate steps. So we can run this, and we're going to run it live one more time. I already tested this once. And this is just the basic testing, making a request to fetch archive the papers, and then just fetching the abstract content of them using a very simple regex pattern. As you can see here, we're fetching an abstract for I think is the paper about Mixtro 87B. All right, so now we're going to define a tool for fetching archive papers, which is going to be an important part of, doing a high quality research report, the ability to, fetch archive papers. So here we're going to say, look, we give this function the archive ID for some paper. And then this function, what this function does is it fetches the abstract from that archive paper and returns it as a string, okay? So we can actually test that so that you see an example. And this is what we get. It beautifully fetches the abstract for an archive ID, all right? Okay, that's great. So we have the ability to fetch abstracts for papers. Now let's get the ability to actually find the URLs, the links that might potentially contain papers, right? So we're going to do search, and we're going to use an API for doing search. In this case, we're going to use SERP API, and we're going to use the Google search module, which essentially we're going to be doing, this is going to be giving the model searching abilities using Google search through an API. And here, all we're doing here is we're fetching information. And the results that we get from this search are going to look like this. They're going to have like a bunch of stuff like position, title, link, redirect link, displayed link, thumbnail, etc. All we want is a snippet containing text from that source, containing information about that source, the title of the source, and the actual link to that source, right? That's all we want. Okay, that's beautiful. So now we take only the things we want from this result dictionary, and we save it under a variable called contexts. Okay, this is an example from the documentation, essentially showing you how to fetch the relevant context information from a search into like a very simple string that can be passed along. Okay, that's what we're doing. So now we have our web search tool. We're going to develop a web search tool. Remember, so far we have an archive tool that can fetch abstracts from papers given the archive ID of those papers. And now we have a tool called search, and essentially this tool is going to be searching Google, all right? And then what this tool is going to be doing is we're going to send a query. It will receive a query, and we'll return 5 results for that query, okay? Why 5 results? I could put here 10, 15, 20, 30, 40, but I think 5 for a simple example demonstration is more than enough. All right, so now we process that information, and we return only the context string containing the title for that specific source, the snippet containing a little bit more information about what that source contains, and the link to that source, okay? So we're gonna do this, and we can even say web search.invoke, and then we can say query LLMs to augment human research. All right, then using LLMs to augment workflows through so now we got a nice little output that contains a bunch of sources, it contains snippets, it contains the titles of those sources, etc. All right, so we have 2 functions so far. Okay, finally, we have Final Answer. Final Answer is going to be a tool that we're going to give to our workflow. And essentially what it's going to be doing is going to be handling anything that might be in the body of our research report. I'm following the example documentation, so they're just cleaning out the steps, which essentially is going to be a bullet point of everything that was done to create that research report. And the resources, we have a bunch of resources at the end for this report. We're going to put it all under a nice little bullet point list, and that's all we're going to be doing. Okay, so that's going to be Final Answer. Now finally, what we have here is the prompt to set up our model, right? And this is going to be the prompt that's going to control something called the Oracle in LangGraph, which essentially is going to be a supervisor agent that will be responsible for calling either the search tool, the archive tool, and deciding when it has enough information to produce a final answer. It's going to say you're an Oracle with the given the user query, you decide what to do with it based on a bunch of tools. If you see that a tool has been used with a particular query, don't use that same tool, the same query again, and also don't use any tool more than twice. And then you should aim to collect information from a diverse range of sources before providing the answer to the user. Once you've collected a bunch of information, use the final answer tool. So essentially, we're trying to give a little bit of guidelines to this Oracle agent on, you have these tools available, and then you're gonna use this tool when you're done, and that's it. So once we've done that, we can go into setting up our model. So we're gonna be setting up GPT-4o Mini using LangChain's ChatOpenAI object, just because everything here is going to be, in LangChain LangGraph. There are different ways to do this, but this is the simplest way. We're going to put all the tools that we created, fetch, web search, and final answer, under a list called tools. And we have one function here that we're actually not going to be using for the final output, just because I don't think it was like absolutely relevant to do it. But essentially, the create scratchpad is a function that takes in the intermediate steps. Remember, intermediate steps are the steps the agent took to solve a task, right? So it's going to be a list of agent actions, okay? And then it's going to create essentially a very nicely organized a list of strings. Actually, the output is going to be a string, but it's going to be creating a bullet point with everything that was done. So I used this tool, and then this was the output, and then next, and then next, and then next, to organize the sequence of steps that were used to perform and complete the task. Okay, and that's returned as a string separated by these skip lines. Now we can set up the first agent in our workflow. The first agent in our workflow, we know because of the state agent that we defined earlier, that the state had the input, right? It had the intermediate steps, and it had the chat history. So it's important that this information is contained in this oracle so that the model can properly process what's coming. So what do I mean by that? This input is going to be a dictionary. It's going to contain these three things. Instead of here being intermediate steps, it's calling Scratchpad, because Scratchpad is going to assume that the input is going to have a key called intermediate steps, which it will, because the input to this oracle is going to be the state that we defined earlier, okay? Then we're going to use the LangChain expression language interface, which essentially is this pipe symbol here, to connect this input to the prompt, okay? So this input is creating three keys to go down to this prompt, and then the keys are input, chat history, and Scratchpad, and they're assuming that the input to this thing is going to have three attributes, right? Three keys: input, chat history, and intermediate steps. So this X here represents the state that's going to be sent as input to the oracle, and then the prompt needs to be able to process input, chat history, and Scratchpad. So if we go back to the prompt, you see that the prompt here accepts input, Scratchpad, and chat history. All right. So everything is set to be just right. Okay. And also the prompt here has this message placeholder, which is great because this is going to contain the messages that are exchanged between the agent and the user as the workflow is executed. Okay, beautiful. So now all we need to do is allow the model, the LLM that we set up, to be able to perform the two invocations. So we bind the LLM to the tools, and then we say tool choice any, because the model can choose any tool the model wants. Okay, so now we run this. So now this is pretty great, because now this can run, folks, as a chain. If you don't know what a chain is a building block in LangChain that allows you to build these complex workflows that involve combining a different model with a different prompt, with tool calling, etc. This is the basic building block. So we can test this, and we can say, tell me something about, I'm going to change this input. Instead of dogs, tell me something about dolphins. So I can send this, and then here we go. What happened here is that the model identified that it should make a call to the tool of web search. So if we investigate, we see that the model identified, I need to call the tool web search, and then the argument should be interesting facts about dolphins, and so on and so forth. So we see that this part of our workflow is working, okay? So now we're gonna put stuff more under functions so that we can actually finally create our graph. So the first one we're gonna build is gonna be called run oracle. So run oracle essentially is gonna take the state. Remember, all the nodes in this graph are going to be taking in as input the state that we define and returning some dictionary with some updated information. Okay, so we're going to say print that you're running the oracle, print the steps that were executed up to that point. Okay, so state intermediate steps, and then we're going to call the oracle. Okay, so oracle was the variable we defined earlier, so it contains that chain that runs that prompt that we talked about. So we invoke that, and then we inspect whether or not we have some tool invocation in the output. Okay, so that's what we're doing here. We're saying tool name and then two arguments, because what this oracle is going to be doing is going to be calling tools. All right. So then we say action output is agent action. And then we give the tool name and the tool arguments, and we return intermediate steps action output. So what did we do? Essentially what we did here is we said, look, we ran the output once, and then we processed that output, and we sent we made sure that the next thing the agent is going to do is perform this specific action. So we explained what's the action going to be looking like. And now we have a router. A router essentially is going to be the thing that allows us to control where things are routed to, okay? So we have one is going to be checking if the intermediate steps is an instance of a list, because it has to be a list, and then it's going to return the tool associated with the last step of the agent. What does that mean? Remember that when we run the Oracle, we get this thing out, get this output, right? Which is a dictionary containing intermediate steps and then action output. When we route, we take in that state and then we go into the intermediate steps. We go to the last thing, the last element in the list of the intermediate steps, and we access the tool. This way we guarantee that we're actually calling a tool. And then if we have some kind of bad format, we return final answer, okay? Beautiful. So now let's just organize how the tool is run, okay? So you see that what's interesting about how LangGraph is doing this is LangGraph is controlling things. It's giving you the ability to control stuff to the point where you're making sure that tools are executed properly in the order they want, and so on and so forth. Now what we're going to do is we're going to write a function called run tool, and that's going to access that information that we fetch when we run the Oracle, right? And then we're gonna access the function that was identified to be called, and then we're gonna call it. So we're calling the tool right here. You see, this is going to be the output of the tool. We're gonna collect the arguments to the tool and the name of the tool from the previous run Oracle and router functions that we executed earlier. And finally, we produce an output and we put that into the intermediate steps again. All right, so easy peasy. Now we have run tool, router, and run Oracle, right? So now that we have all of those things, we can set up our graph. So we start by initializing the graph with a state, and it's going to be that agent state we've talked about earlier. We're going to add nodes for these different parts that we've defined. So we have a node for the Oracle. So essentially the node for the Oracle is the run Oracle function. We have a node for running the fetch archive tool, which is the run tool. We have a node for web search, which is run tool. And we have a node for final answer, which is run tool. Now, one function for these three different tools. Does that make any sense? Yes, it does. Why? Because if we go to run tool takes a state, right? And what it does, it analyzes what is the tool that the Oracle, right, the model identifies should be called, and then access that information and runs that specific tool. So this is a general function that can be used to call different tools. Instead of you having to write a function to run the fetch archive tool, a function to run the web search tool, and then a function to run the final answer tool. You see? So this is just an abstraction to allow you to run as many tools as you want with just one definition. Okay? Beautiful. So now that we've done that, what we're going to do is we're going to set an entry point. Setting an entry point just means where do we start in this graph? And obviously that makes total sense. We start in the Oracle, right? It's going to take in some input, which is going to be the topic of a potential research report. And it's going to route to whatever tool, what to do, and giving the inputs, the parameters, etc. Now, since the Oracle has multiple options of outputs that can come out of it and nodes to send to, we need to add a conditional edge to the Oracle. So the source is Oracle. And then because this is a conditional edge, we need to give it a function that is a condition, that adds some conditional logic to this conditional edge, okay? So essentially, if you have a conditional edge, you have to add a function that implements a conditional logic, okay? And in our case, it's going to be the router. Now, let's understand why the router is the logic behind the conditional edge. If we go back here and we look at router, we look at router as a conditional logic, right? If else, that's a conditional logic. And then we say, look, if you have intermediate steps and it's an if it's an instance of a list, then return the tool. That's it. Okay. So the router essentially says, okay, it's either you have, if you have a tool, or we return the string that calls the final answer tool. Okay. So pay attention to what that means. That means that we're saying, look, the router routes from the Oracle to some tool. And the way to do that through an abstraction to be able to route to as many tools as we want is to say, look, we either route to the tool that was identified by the agent to call, or we return final answer. And final answer is a string that's going to activate calling the final answer tool. Okay, that's it. So that's why final answer is identified here as final answer. Okay, which is weird to explain it like that, but that's what we got so far. Okay, so we added a conditional edge from our Oracle to the router, right? We already have nodes for all these different things, and we also have the node for the Oracle. All we got to do now is add edges for everything that can come out from the tool back to the Oracle. Okay, so essentially we're saying for all the tools that we have, unless if it's not final answer, I want you to add an edge back to the Oracle. Okay, so you're gonna see what that looks like in a second. And then we add an edge between the final answer tool to end. So we make sure that if the model calls the function final answer, the workflow is done. All right. And then we compile the graph. And when we visualize, it's very simple to see what we've done. The Oracle can call the fetch archive tool, and the fetch archive tool only can send back information to the Oracle. Same thing with web search, and not the same with final answer. When the Oracle sends the output to final answer will definitely end the conversation. All right. So that's what we're doing here. And now, so let's run this and let's run this. Beautiful. And now we can say something like write a report with explaining 5 ways through which LLMs can be used to enhance human research. And I'm going to add a little prompt here. Make sure to include all the sources used with their respective URLs. I'm just going to say that just to see if we improve a little bit the output that I got earlier. All right, so I'm going to run this live so that we take a look, and I'm going to skip this part where it's running, but you can already see that the model is invoking tools, and then the tools are being invoked with different inputs, and the model is collecting information from those invocations, and then hopefully it's going to produce a pretty good report. So now we have a report, and if I go here and I say out, I get this string containing everything that happened, okay? And if I want the absolute output, the last thing, I would have to access the intermediate steps. So I would have to say intermediate steps, and then I would have to say -1, and then I would have to say tool output. No, tool. Oops, sorry, folks. And then I will have to say, what's the name of the attribute? What is the name of the attribute? Yeah, tool input. It's actually tool input. Yeah, I forgot. There you go. So this, folks, look, this tool input now has introduction, research steps, main body, conclusion, sources. So essentially the function final answer added all of these elements to our final output containing organized resources, etc., etc. So this is really nice. The problem is we want a report in a markdown, all organized, so we can just read it. So let's write a little function. That's what they did, and that's what we're doing here. And we're going to write a little function called build report. It's going to have it's going to take in this dictionary output, which is going to be this, right, containing all the organized information, and it's going to just format that as a nice markup. I'm even going to add like, yeah, I'm going to have some headers here like this. Look a little bit better. There you go. So now we run this, and now when I run this, this is what we get, folks. This is our output. -1. Ta-da-da, ta-da-da. Yeah, this is our final report, folks. Now look at this. We have a very quick intro. We have a report containing exactly what we asked for in a pretty interesting, pretty nicely organized way. We have the references to the papers, and you can cross-check them in the resources here with the respective links that we can check. So I'm going to be checking one, transforming clinical trials, emerging roles of large language models. That's a super relevant resource for my particular example. And we can do the same thing with the other examples. So you see that the report is completely referenced throughout, just like a real research report would. And we have the links to cross-check that information. So even though it's a slightly smaller, it does contain high quality referenced information. So let's just sum up what we've done so far, right? Obviously, there are many things that we could do here to improve it, like improving the body of the report, asking for things a little bit more complex, adding for more sources, adding for like a more essay style report rather than this bullet point version, and less simplifications. However, we get something that's short, to the point, high quality, well organized, completely references that are not, as we can cross check them here, they're not hallucinations. They're actually super high quality examples. You see proposal for responsible development. These are perfect sources and high quality. You see Nature, NCBI. I think we have PubMed. We have Sloan MIT. So we got good sources for the report, and we successfully built it, right? And just from a simple web search plus archive search. In this case, I don't think we actually end up using any archive papers, but we could make some slight changes to do that. So I guess that's it for today, folks. Thanks for watching. Don't forget to like and subscribe, and see you next time. Cheers.